in theory, this is all stuff we know. Okay, so let's see what we can get. Accumulation and net change. So accumulation versus net change. This is kind of like the difference between distance traveled versus displacement. Distance traveled. So if I start at this point, and I go this way for 2 meters, and then I come back this way, and I go from here to here, I travel, so I'm going in the negative direction. If I go negative 6 meters, in the end, I get to a point which is from my starting point, where am I at? What is this point? This point would be negative 4 meter point, right? So your displacement after everything that was said and done, you ended up at negative 4. Your net change is negative 4, right? From where you actually started from. But if I ask you what the distance traveled was, the distance traveled would be what? 8, right? Because you went 2 this way, you went 6 this way, adds to 8. So there's a difference there between displacement and distance traveled. Okay? So let's look at example number 1. Example number 1, we have figure 8.1 shows the velocity function looks like that. So you have your velocity function is equal to t squared minus 8 over t plus 1, is it? Squared like that? Or is it not? That's correct. Okay, so this is what we have. This is our velocity, right? Velocity, in order to get the velocity, what did I do? I took the derivative of the distance, right? So this is going to be equal to the derivative of the distance, right? So if I look at, and what was the question? The question is particles moving along. Describe the motion. What's going on with this? So let's describe the motion. If I plot this, it looks, so I'm going to go like this. So this is the velocity. This is time, right? So your velocity starts out being negative. Okay, so no matter what point you're starting at, if I go from here and we call this way positive and this way negative, where am I going to go? Well, to the left, right? I'm going to go this way, right? So I'm going negative, right? Negative till I get to this point right here, which is time, what do they call that? Time 5, I guess. Is it time 5? Or is that time 1.25? 1.25, I go this way and then I stop going this way, right? Because my velocity is what? 0. And then from then on, I'm going positive. Right? From then on, I'm going positive, right? So if they ask me to describe the motion, I would say that the particle is moving to the left. From time 0, it starts going moving to the left. And then at time 1.25 seconds, it turns around and it goes that way. Because from then on, now your velocity is increasing, but it is in the positive way, right? It's in the positive direction. So now you're going to go this way. Okay? So that'll be your brief description of what's happening there. Okay, flip the page. Go to example number 2. Example number 2 uses the same exact function. Suppose the initial position of the example is 9. So you're going to start from point 9. So the initial position, S sub 0, is going to be equal to 9. You start at 9. Okay. So what is the particle's position at t equals 1 second? At t equals 1 second, you went from here to here, right? So you're going to go from here somewhere to probably around here somewhere, right? Right around here. Okay. But it's not stopping yet. We're still going in this direction, right? So if I want to find the displacement of that time, I would have to take, I want to find the S. So if I find the S, I have to take the integration. I have to integrate this guy. So the integration of t squared minus 8 t plus 1 squared from 0 to 1, right? And this is going to be dt, obviously. Okay. So if I do that, I'm going to get what? I'm going to get, well, let's just go ahead and do it. It's going to be 1/3 t cubed plus t plus 1 over 8. If I take the derivative of this, it's t plus 1 to the negative 1, right? So when I take the derivative, it's going to become, the negative is going to come over here and it becomes t to the negative 2, which is what we want it to be, right? So this here is our anti-differentiation of this guy right here. Okay, and then I'm going to go evaluate that from 0 to 1. Right? So when it's 1, I get 1/3 plus 8 over 2. 8 over 2. And then I have to subtract from that my 0. So that's going to be 0. And this guy's going to be 8 over 1. Right? So if I do this, I'm going to get 6, 2, 24, 26, minus 8. Not 8, 6. 26 minus 48 minus 22 over 6, so it's going to be minus 11 over 1/3, right? So it's a minus 11/3. But where did I start from? What was my starting point? Nope. 9. I started from 9, right? So this is my displacement from 9, right? So in other words, if I want to find the end position or the position at 9, it's going to be my initial starting position wherever I started from plus my net change, right? My net change, plus my displacement. So this will be the displacement, right? This will be negative 11 over 3. 9 minus 11 over 3. 27, 11. 16 over 3. That's an odd number. Okay. All right, so that's the answer. 16 over 3. Does that make sense? Are we good? You understand how we use the integration here? Okay, because I wanted the displacement to get the s, I had to integrate this guy. Since the derivative of this is this guy, right? We're doing the anti-differentiation. Okay, that was A. B at t is equal to 5. T is equal to 5. So t is equal to 5. So there are 2 ways to do this, right? Since I know from 1, I can go from 1 to 5 and just add it to that. I can just go 0 to 5, right? Starting from where? If I go 0 to 5, where do I start from? My starting point was s of naught, right? What s at 0, right? Which would be 9 again, right? So in here you would go 5, right? 0 to 5. We'll just plug and chug again. So 5, I get 125 over 3 plus 6, so that'll be 4 over 3, right? 8 over 6. I'm going to subtract the 5, and I'll start to 0, right? Again, this is 0, and this, if you want to put 0, it was 8, I guess. 8. Okay, so I get 129 over 3 plus 8. What do I get? This is 43, 51. Is 51 the answer? 44 or 35. Well, I missed something. It's supposed to be 35. Why is it 35? What am I missing here?
Supposed to be 0 plus 8.
Very good. Thank you. Right? because it was this plus this at 0, right? This is 0 plus, so it becomes, now it becomes a negative, so this is a negative. So I get 43 minus 8, which is 35. Okay. So that's the third, that was a displacement, right? This is the displacement. Right, 35 is a displacement. But I started again from 9, so it's 9 plus 35, which is 44. 44 is my end point, right? Okay, so that's good. So in example number 3, we're using the same thing again, but now they're asking for the total distance traveled. Total distance traveled, so I'd have to do what? Because the distance traveled here is going to be from here to here, so it's going to be 0 to 1.25, and it's t squared minus 8 over t plus 1 squared. This guy dt, and you would have to subtract that, right? Because it's a negative value here, right? Right? And then you would have to add from there 1.25 to 5. Same thing, t squared minus 8 over t plus 1 squared dt, right? Or another way to write this is you can write this as t squared minus 8 t plus 1 squared. You can just do the absolute value and go like that, right? Same thing, same result, right? In other words, as long as you make this little guy here become positive again, and that's what you're trying to achieve. And that's why you had the negative here. If it was a negative value, so I put a negative to make it positive. Or if I just say the absolute value, that means this side gets flipped over and it's positive. Okay, so if you're going to use NINT, you're just better off doing it this way, right? Correct? Because you can just plug it in your calculator and it should do all the work for you. Right? So the example number 3. And I'm not going to go doing this. If you do it, you get 42.59. Let's go to example number 4 on page 388. By the way, those of you who are to take the test, this is one of their favorite questions. Particle in motion. Love that question. So make sure you are well versed in particle in motion questions. Okay, example number 4. Example number 4, we have modeling the effects of acceleration. A car moving with initial velocity of 5 miles per hour accelerates at the rate of that. So your V naught is going to be equal to, or V sub 0 is going to be equal to 5 miles per hour. 5 miles per hour, and your acceleration equation is given as 2.4 t. 2.4 t, and it's miles per hour per second. And that's pretty weird, okay? This is a weird unit. Miles per hours per second, miles per hours per second. So that should give you a pause here. And it makes sense, right? Because it's miles per hour, so it is a length per time. Per second is going to be length like that. Same thing over, and what's our gravitational constant, right? 9.8 meters per second squared. Same thing, meters per second squared, right? So it is in the right, correct unit there. I mean, correct dimension. Okay. But you should think about that. So it is for 8 seconds. So for 8 seconds, it goes at that acceleration. A, how fast is the car going when the 8 seconds are up? Okay, so in other words, this is, I know this, right, as 5 miles per hour. Okay, what I need to find is the delta V, how much it changed from 0 to 8, right? So I'd have to take the acceleration and take the integral of this, right? Because the derivative of this is this, correct? So we're going to go 0 to 8, 2.4 t dt. And this is going to be the change in your velocity. It's going to be 1.2 t squared, 0 to 8, 1.2 times 8 squared. 8 squared is 64 times 1.2. Gonna cheat. 76.8. 76.8. Since I was at 5, and this is the delta V, so my V at 8 seconds is going to be what? It's going to be this guy plus this guy, right? So it's 81.8. 81.8 would be that. Okay, B, how far did the car travel during those 8 seconds? Okay, so how far did it travel? So this is your, so if I went just like this, it's going to be what? 1.2 t squared. This is going to be miles per hour, right? Correct? So I integrated from here to get to the velocity. So I have to integrate it one more time to get down to displacement, right? Or S, okay? So S is going to be equal to another, I'm going to do this one more time. It's going to look like this. And I'm going to go from where to where? 0 to 8 again, right? So I'm missing the 5. This is the initial velocity, 5, right? dt 0 to 8. 0.4 t cubed plus 5t from 0 to 8. So it's going to be 0.4 times 8 cubed plus 40. And then if you do that, what do I get? I get 244.8. And what do I get? I get miles per hour times second. Oh, this is weird, right? So this is what this guy is coming back to bite us. Okay, so I have miles per hour times a second as a distance. So what is my end distance? Am my end distance miles? Is it feet? What is it? So I have to do some unit correction here, right? Or unit adjustment, I guess. 4.8 miles per hour times second, right? And I have, so let's go ahead and make this change first. 1 hour is how many seconds? This many seconds, and I had seconds on top. So now the hours cancel out, the seconds cancel out. So my answer will be in miles. So I have 244.8, it traveled this many miles. So it's going to become a really small number. What's the number? 0.068 miles. Or I can go to feet by multiplying this by what? How many feet in 1 mile? 5,280. 0 feet. Right, if I do that, and then how many feet? 359 feet. So this is a much better answer. 359 feet, right? Be something I can picture versus 0.068 miles. Okay, we will save the consumption over time for the second half. Let's go ahead and get working on our homework.